Okay, so in the last notebook, we looked at our data, we did some analysis of the variables, and we also started to see a few potential issues there, like that there were zeros in some columns where there shouldn't be. So in this notebook, we're going to start drilling into those issues and making a few changes to our data set to make it ready to prepare it for our machine learning models. So let's read in our data set. And again, this is just a quick reminder of what our variables look like. So we talked about one issue of being that there are some zeros in here, for example, with BMI and blood pressure. So chances are these are not patients who have a BMI of 0. These are probably missing values. So maybe the researchers didn't collect the patient's BMI, or maybe just something was wrong with the data and it didn't get saved or something. So missing values can look different. So sometimes you'll see them as NaN, which means not a number. In a SQL database, you'll see it as null. In this case, the data fills it in with zeros. So a few questions for you to consider. So why might they be missing? Does every column with a 0 mean that it's a missing value? What are some potential problems of building a classifier with missing values, and what should we do about them? So first, to answer this question, does every column with a 0 mean that it's a missing value? Well, no. So pregnancies, for example, that's valid, that someone could have 0 pregnancies. I don't know what outcome also is another one. So we know that 0 means that they don't have diabetes, and that's valid. So we don't just want to totally do away with the zeros. So the next question, what should we do about these? So there are a few options. So one option that you could do is you could drop all of the rows with a 0 there. And that would be a way of saying that, okay, we know that something is wrong with this patient's data. Let's just exclude them from our analysis. So that could be good, but there are some potential drawbacks here. And I'll leave you to think about that and consider why that could be. So another thing that we can do is we can do something called imputation, which is where we calculate some other value that we will substitute in for the missing value, which won't affect our analysis too much, but will allow us to keep using that row and not have to throw away that data. So the way that we're going to do this is we are going to look at these columns which have missing values, and we're going to calculate the mean of those columns. So what is the average value for each of those columns where it's not 0? And then we will replace any 0 with that mean. And that's just kind of a way of substituting this kind of generic value in for our zeros. Okay, so the ones that we want to address with missing values, so let's see, if we look at the min row here, we can see which ones do and don't have missing values. So pregnancies, that's valid. We want to allow there to be a 0 in the pregnancy column. But glucose, that's not as good. So let's add the string glucose in here. Skin thickness, that's also problematic. Insulin, BMI, and let's see, this doesn't have zeros, this doesn't have zeros, and this we want to have zeros, so I think that this is good. Okay, so these are the columns that we're going to want to replace zeros with the mean value. So how we're going to do this is we're going to loop through each of the columns. So we'll do a for loop of for call in calls with missing values. And first, we're just going to subset the database to be, or the data frame, to only be instances where that column is 0. So we can say not missing is any place where it is not 0. Then we're going to generate the imputed value, which is going to be the mean of that column. So the reason that we left out all the rows with 0 is because these are the bad values. We don't want these zeros to skew the mean that we're calculating. We want it to be an actual mean. So now we can calculate the mean value here. And then we'll use this method where we'll take the column and we'll call dot replace. And we're going to say we're going to replace any 0 with this imputed value. Oops. Okay, so once that's run, let's look at our data frame again. So now you can see pregnancy still has a minimum of 0, but glucose now, it's not 0, it's 44. Oh, I left out blood pressure here. So I'm going to rerun this. Okay, blood pressure now has 24. Skin thickness of 7, insulin 14, 18. Okay, so this looks better. We've dealt with our missing values now. We know that that's not an issue in our data set anymore. So next we're going to break up our data. Now that our data has been cleaned up, we're going to break it up into two different variables. So we introduced the terms earlier of features and labels. So what a feature is those are our predictors, right? So those are what we are using to predict whether or not they have diabetes. And so these are any of these columns, like pregnancies, glucose, blood pressure, etc. The labels tell us what class they're in, and so that's the outcome variable. So what this is in this data set is the feature variables are any column except for the outcome variable. And so typically we call the features in the data set x. So if you think back to like algebra, often x is the independent variable, y is the dependent variable, and that's what we're doing here. So we're going to take our data frame and we're going to drop one of our columns. And the column that we're going to drop is outcome. And that way we'll have all of those feature variables here in one place. And then y is going to be the outcome column. So here's the top of our data frame of our features, and here is the top of our labels. Okay, so now that we've separated, the next thing we need to do is we need to split up our data set into something called a test-train split. So ultimately, our goal is to be able to predict whether or not any patient has diabetes. But we only have around 800 patients here, so how do we know that they're going to do a good job whenever new patients come in to be predicted? So a common way to deal with this is we're going to take a portion of our data and we're going to leave them out during training. And that way our classifier is never going to see what this data looks like. And that will allow us to test our model on these new patients and get a sense of how well does it generalize? Is it going to do a good job when it sees new patients? So a few questions to discuss. So why is this important? How should you select the data? What are the costs inherent to taking out the data for testing? And how much should we use? What are the proportions that we should be doing? Okay, so for what we're going to do now is we're going to split x and y up into train and test sets. And a common convention is that the training set will contain 80% of the data and the testing set will have the remaining 20. So we're going to import this function called train test split. And we call this on our x and y. And we're going to say that the train size should be 0.8. Okay, now we can see that our training set has 614 rows, and our test set has 154 rows. Okay, so we've gone through these two notebooks now, and you can note that all that we've been doing now is analyzing the data, cleaning up the data, splitting the data. We haven't done any actual machine learning. And this is very much characteristic of a machine learning project, where you spend most of your time working with data and wrangling data. And in this case, they gave you this clean data set that was already created, but usually you're using SQL and using databases to create it. But what we're going to do now is we've cleaned up our data, and we're going to save these variables using the pickle package. So if you haven't used pickle in Python before, what this does is it saves objects to disk, and then you can load them back the next time you run Python or when you're in a different notebook. Okay, so we will call pickle.dump and we'll pass in all of this data to this file diabetesdata.pkl. And now if you go to that folder, you should see that this pickle file is here. If this isn't here, then something has probably gone wrong, and so make sure that you can resolve that. Okay, now we'll finally go into our last step of doing the actual training and evaluation. And that is broken.